and hello to everybody. This is video about manufacturing process of a Tesla car second generation model Tesla S. Tesla S is a manufacturing electric car that's made a big impact to our environment and also our nature. This manufacturing process video is held at Fremont, California, United States. It's a factory of a Tesla S factory. This car is sold about $50,000 US at United States. Okay, let's begin this journey.
Bodywork. 19-inch alloys. And a $50,000 price tag. At first glance, this car is the latest in a long line of high-end sedans. But that is where the similarities end. The Model S is a totally different type of car. Tesla believe it can lead a revolution and change the face of motoring forever. It's the first ever mass-made premium sedan powered purely by electricity.
Bicycle makers appears to be struggling with welding together a mostly steel vehicle as opposed to the primary aluminium bodies of the Model S. The Model S aluminium and steel body together required more welding rather than the adhesive and rivet in aluminium bodies. How well can increase the damage in the vehicle in the accident and can lead to rattling and squeaking as the car ages.
Meticulously trained 130 sophisticated robots over a year and a half. One of the last robots still to be programmed is a multi-point welding robot. It will be used to join the car's underbody.
These are pretty busy robots, so we gotta make sure that our tack time is good.
A robot's work is only as good as the man who trains it. Brad Johnson is a welder with over 25 years' experience at the highest level.
Getting this done today, we'll have the teachings all nice and smooth, and then we can start running 100% in full automatic.
That sounds good.
The space in which the robot operates is treated as a three-dimensional grid. The head can be manually guided to any point using a teach pendant.
There's our start point and our weld position.
Brad guides the robot millimeter by millimeter and uploads the coordinates. The robot works out the most efficient route and runs the program.
Tesla Model S body is constructed from aluminium and they are produced of aluminium coils. The coils are unwound, flattened and cut in blank machines. The total weight of aluminium used is around 410 pounds. It is about 190 kilograms. Then the robots transfer the aluminium coils to the tandem press line, and the machine press one part every 6 seconds and create 5,000 in a day.
Everything is perfect along the way. So we are really gearing up towards a production ramp-up.
Over the next few weeks, the factory will test manufacture a limited number of Model S. If the line doesn't perform with these cars, the company will be forced to miss their deadline. Tesla's electric revolution would be over before it started.
A very, very important moment is the birth of Model S in our Tesla factory. And it's where, you know, the rubber is going to meet the road, so to speak.
The process begins in stamping. To increase the battery's range, the company have decided to build 97% of the Model S with lightweight aluminium. It's an extremely rare feature in a mass production car due to the cost. Every Model S starts as one of these. The roll is loaded into the mechanical cutting machine. Once cut, the panels are passed to the stamping press.
Tesla S holds the record for the fastest acceleration of any production vehicle with a rolling start to 60 miles per hour in Motor Trend test with 2.28 seconds, which is 0 to 100 km per hour at 2.36 seconds, and indicates ludicrous mode, although other independent tests have placed it behind with Porsche 918 Spider.
To meet the challenge, they buy the largest available stamping press in North America. It's one of the first pieces of equipment they install. Over 3 stories high, it has to be transported from Detroit on 70 trains and then entirely rebuilt. The immense pressure from the stamp allows them to press the complex body shapes needed for the Model S. It can be mounted with different heads, known as dies, that mold the panels into a wide variety of shapes. Robotic arms feed the 4 stamps. Each stage forces a more detailed 3D shape, producing stacks of floor plates. These lightweight aluminium parts improve the Model S's power-to-weight ratio, which helps increase the performance and range. The 2 things that obsess co-founder and technical chief, J.B. Straubel.
Any ideas on how we can make it better? Performance and range were the 2 big issues that needed to be improved, and that's where we've put most of our focus on the technology and powertrain.
Powertrain manufacture, 2nd floor. This is where they build the heart of the Model S, the motors and battery packs. Tesla know the electric powertrain will define their cars, so they push to advance the technology themselves.
This is an extremely exciting field where inventions continue to happen even faster than they did, in the years previous.
Tesla's solution to improving battery life appears startlingly simple. They use thousands of small lithium-ion cells, similar to laptop batteries.
Body and chassis are built mostly from aluminium, which come from bauxite ore. Aluminium is lightweight, which helps to maximize the range of the battery beyond that of other EVs, which stands for electric vehicles. The total amount of aluminium used in the car is 410 pounds, which is also equal to 190 kilograms. The underbody of the Tesla Model S is made from ultra high-strength titanium, which protects the battery from nearby any roadside force or piercing. The interior of the car, whereas plastics are used mostly from petrochemicals, the leather is derived from animal skin, which is mainly cow hides.
The run through the automated line reaches the Model S exterior. The Model S body is made up of 14 different sections. To speed the workflow, Tesla construct each section at separate sub-assemblies. Door sub-assembly. The internal frame is joined to the exterior panel. As the robot's pincers come together, they fire a rivet and join the aluminium sheets. Over to the right, side body subassembly. One of the most advanced aspects of Tesla's robots is that each arm can perform a variety of different tasks.
We have to use all the gamut of technology to make the aluminum joint between stamping and welding and riveting and bonding and all these things using robots that are multitasking.
"10 years from now, Tesla will change the perception of what mainstream cars can be. And it'll become clear that electric cars truly are the future."
The Tesla Megafactory may have just built its place in history.